D.D. Palmer even hinted at this, 110 years ago? When he said chiropractors correct abnormalities of the intellect as well as the body. So, the essence of the talk this morning with you all is neuroplasticity, the science of change, the ability of the central nervous system to reorganize itself. The simplest form of neuroplasticity is learning. We learn new tasks. And we create new synapses. We even have new cells that get sprouted. But we also know there's negative neuroplasticity. We know that there are maladaptive changes that take place in the brain, either from chronic pain or even musculoskeletal dysfunction. So what I'm going to try to convince you is that, yes, you too are a chiropractic brain surgeon. Now, I wouldn't put that on your website, but I want to show you that in the power of your manipulation, the influence that you thought was limited to the spine has an effect in the brain at the central nervous system. So to begin, I'm going to back up, and I want to ask you to do a simple experiment with me. And I give you permission to do this, so it's okay. I want you to turn to your neighbor and give them a very strong pinch. A good pinch. A painful pinch. Come on, Rob, get in there, pinch them. All right? So let's look at the International Association Study for Pain, the definition of pain. They say this is an unpleasant sensory. Okay, we'll stop right there. Was that unpleasant? Yes. Right? That was sharp. So if we back up and we say, let's look at this whole chain of events. We started with the stimulation of a delta fiber, a thinly myelinated but pretty fast conducting neuron that carries pain almost directly to the primary sensory cortex. We call this fast pain. This is your pinprick pain. So when you felt that pinch, as soon as, before you even felt it, you were withdrawing from it. Right? That's an amazingly quick system. And it's the A delta fiber, the fast pain that's carried to the primary sensory cortex. But that's not the only fiber. Because after the pinch, what did you feel? You felt kind of an ache. You felt a little bit of a burning quality afterward. That's the C fiber. This is a non-myelinated fiber. It conducts slowly, and only 10% of those fibers go to the primary sensory cortex. What's really important about these fibers is that they follow a similar course, but they are very divergent. So a lot of these fibers will terminate in the brainstem, reticular nuclei, the descending inhibitory structures like the RAF nucleus and periaqueductal gray. They'll also go to the interlaminar and posterior complex through the thalamus. But here's the important point. This is where you need to perk up and listen, because the C fibers are also diverging into areas of the limbic function, limbic system. And what do we know about the limbic system? The amygdala, the hippocampus, parahippocampal gyrus, all of these structures. What do we know about them? These are what? These are emotional centers. These are emotional centers and also information processing. But the point is that you felt that sharp pinprick pain. That was one response. But then you felt a lingering, burning, aching quality from the C fiber. But that goes to entirely different regions of the cortex. So we know that this is an unpleasant sensory, A delta, and emotional experience. Pain becomes an emotional experience. And I'll prove it, because you know that a pinch of love A love pinch feels a whole lot different than a pinch that takes place in a heated argument.